Okay, so today we're going to derive slash prove the Pythagorean in two different ways. So the Pythagorean theorem states that we're given a right triangle with legs A and B and hypotenuse C, then the sum of the squares of the legs must equal the square of the hypotenuse. So the first and most common approach, or at least what I've seen most commonly, is so we're going to solve directly for c squared. And so to do that, we're going to imagine that c squared represents the area of a square, right? Because it's length times width. So a square with side length c has area c squared. So we've drawn this square. Well, let's go ahead and draw the triangle that we have. And, well, that's going to be the same on all four sides. And so what we have is a square inscribed in another square. And so to get the area of this square in the middle, which has area c squared, we're going to find the area of the bigger square, and we're going to subtract the areas of the four triangles. So c squared is going to be equal to the area of the bigger square, which is what? Well, the side length of the bigger square is a plus b, and then we're going to subtract 4 of these triangles, which have area 1/2 base times height. And so we have a squared plus 2ab plus b squared when we FOIL out that expression. 4 divided by 2 is 2, and the 2ab's cancel out, and so we have a squared plus b squared equals c squared. Okay, so easy enough, right? So here's a second approach. I think this approach is actually easier to me, but regardless of whether you think it's easier or not, I'll just present to you another way of doing it. So let's do this triangle again. We've got A, B, and so we want to find side length C. That's for this whole length. And I'm drawing that out here because in here I want to split this up into two components. So I'm going to send a line perpendicular straight over to this corner. So these are both right angles. Then C is going to be this component here, which we'll call X, plus this component here, which we'll call Y. And let's call this angle theta, and let's call this angle phi. So in order to find this X component, let's look at this triangle here. So it's got a leg X and hypotenuse A, and we know that the cosine of theta here is going to be the adjacent over the hypotenuse A. And if we do the same thing for this other triangle, we have a leg Y and hypotenuse B and angle phi, and so cosine of phi is the adjacent Y over the hypotenuse B. So if we want to find X and Y, X is A cosine theta, and Y is B cosine phi. Okay, so if we want to find c, it's just a cosine theta plus b cosine phi. Well, okay, the step before that is c equals x plus y, and then we just found what x and y were. So, well, we just need to simplify this. So, how can we describe cosine theta and cosine phi in terms of what we know? In other words, not in terms of the angles. Well, we can again look at the original triangle, the large triangle. So we have theta and phi. So looking at this triangle, cosine of theta, and we know this side is c, cosine theta is adjacent a over hypotenuse c, and cosine phi is adjacent b over hypotenuse c. So if we substitute those in here, we have a times a over c plus b times b over c, which is a squared over c plus b squared over c. So we can multiply both sides by c, and we get c squared equals a squared plus b squared. And that's it. Hope you enjoyed it. Let me know what else you'd like me to prove.